Okay, here we go. I want your undivided attention up here. I'm going to take some time to do this. This wasn't in the plan, but what you're going to pay me back for, the way you're going to pay me for this is you're going to have all that stuff put away. You're going to be really focused up here. So on these, solving absolute value inequalities. Which, if you're really just starting from scratch on this, you're going to have to go do some reading, and you're going to have to look at the class notes and the instructional videos. Hopefully you're not there, because we've done a few of these, but I think a couple examples ought to get you back on track. But if what I'm doing right now today is not making sense, you're behind. I know we've had a lot of days off, but I have put a ton of resources up there, and it's going to be on you to go in and use those resources. I mean, that's because we got to get through a certain amount of stuff in order for this to be Algebra 2, for you guys to be ready for the next class. And I guarantee that's my top priority, is that's got to happen. So, I get it. The days off, it's not always the most fun thing in the world to sit there and do math. But if you've kind of put that off a little bit for a while, you might have to spend a little bit of time going back and refreshing yourselves on this a little bit, okay? But having said that, let's work on a couple of these together. Probably this will get you where you need to be. I bet it will. So what do we do with something like this now? Let's think if we've got an absolute value inequality. We were going to write our answer as a compound inequality, right? If the solution is, if we need an OR, we're going to use the OR symbol, right? If there's no solution, we'll enter NS. And I want to look at one like that. How could you get one that's a no solution? We'll look at an example like that too. Okay, so what do we do first? When we're solving an absolute value equation or inequality, what do we always do first? Isolate the absolute value. Good. So what are the two steps we got to do to get the absolute value by itself? Good. We got to add 10 and then divide by -2. Good. So you guys this is not bad. You guys are you're knowing what you're doing. We just slight tune up here. I'll be fine, I think. So if we add 10 to both sides, what do we get? So those guys cancel, and we get -2 times the absolute value of 4x minus 40 is less than -144, right? Okay, now we're going to divide both sides by -2, you said. So those guys cancel. That's good. And we end up with absolute value of 4x minus 40 by itself. We got it isolated. Over here, we're going to get -144 over -2 is positive 72. What do we have to do? Good, we got to flip the sign, don't we? Because we're dividing by negatives, that's got to get flipped around, right? Okay, so now we isolated the absolute value. That's the first thing we got to do. And then here's where you got to remember what the relationship is. There's two possibilities, right? And let's review those real quick. If we get the absolute value of something, let's just call it u, is greater than some number a, then what do we do with that? Right? If the absolute value is greater than a number, is that going to be an and or an or? It's going to be an or, right? Because we're asking when is the absolute value really big? Either it's going to be really big and positive, or it's going to be really big and negative because the absolute value makes it positive. It's got to be bigger than a. It's got to be either more positive than a or more negative than negative a, right? So the trade we make is either u is greater than a, or that's my or symbol, u is less than negative a, right? Okay, so that's what we got to do here, isn't it? We've got an isolated absolute value is greater than a number, so then whatever's inside either has to be greater than 72, or whatever's inside has to be less than negative 72. Then we'll just solve both of those. Well, what's inside? 4x minus 40. Remember that we can't do anything inside the absolute value bars, right? Like we can't, sometimes people, they want to do things like they want to add 40 to, but you can't do that because everything inside the absolute value bars is off limits. You can't touch anything inside the absolute value bars. You got to get rid of them first. And then once we get rid of the absolute value bars, then we could do algebra like we normally do, right? So we get these two, we get an OR inequality. Either 4x minus 40 is greater than 72 or 4x minus 40 is less than negative 72, and I'll just solve them both. What are the two steps to get the x by itself? Add 40, good. So 4x is greater than, what is that, 112? And then I just divide by 4, right? So I get x is greater than, what's that going to be, 25 and 3, so 28. There's one possibility. Or, what do we get over here? If I add 40 to both sides, I get 4x is less than negative 32. If I divide by 4, x is less than negative 8. So there's my answer. X is greater than 28, or x is less than negative 8. Right? Okay, no biggie. We can do that. How about one like this? And I picked the hardest ones I could. I mean, if you can do these, you can do any of them, right? So what about this guy here? So we got to add 10 and then divide by negative 2. Good, so we're going to isolate the absolute value. Very good. So we get negative 2 times the absolute value of whatever is greater than negative 16. You almost don't even have to write what's in there because you can't touch it anyway, right? And then you told me divide by negative 2. Cancel, and I get my isolated absolute value. I get an 8 on this side. What do I have to do? I got to flip it. I'm dividing by negative, right? So I've got to flip it around. Okay. Now what's my rule here? If I have an absolute value of something, call it u, is less than a number, that's the end. And you just got to remember that. I mean, that one's just kind of on you. Make a couple flashcards if you need to or something. But you got to remember that. So this is the one we trade for. This means that u is small, right? Either it's going to be a number that's smaller than a, or if it's negative, it can't be less than negative a. It's got to be in between negative a and positive a, doesn't it? For its absolute value to be less than a, right? So we make the trade, whatever's inside the absolute value is greater than the negative number and less than the positive number, right? So that's what we do here. We've got an isolated absolute value of something, call it hand. The absolute value of hand is less than 8, then that means hand has got to be greater than negative 8 and less than positive 8, right? So whatever's inside the absolute value is going to be between the positive and the negative values of the number, right? And what's in there is a negative 4x minus 40. So what are the two steps to get the x by itself? Add 40, good. And I'm going to do that to all three parts of this compound inequality, right? So then those cancel, and I get a negative 4x. I'm going to get a 48, and negative 8 plus 40 is positive 32. Do I have to flip any signs yet? Not yet, because I haven't multiplied or divided by a negative. Now I'm going to divide everything by negative 4. So those cancel. So I've got my x, 48 over negative 4 is negative 12, 32 over negative 4 is negative 8. What do I got to do? Got to flip them. So I divided by a negative. So all those get flipped. That's written backwards though now, isn't it? Yeah. Right? I got to take the whole thing and I got to flip it around. So I get the negative, the smaller number on the left and the bigger number on the right, and the inequalities point the right direction, right? So now we're going to say, what does this mean? X is greater than negative 12. I want to write it like that, don't I? Greater than negative 12, and X is less than negative 8. So that's my answer. Looks like a number line. Say it again. Well, we still had to do it though, because there's two different kinds of switches going on. Right? These switched because they had to, because I divided by a negative. These didn't really switch. All we did was we just reorganized the way we said it. We didn't really change anything. We're still saying X is greater than negative 12 and X is less than negative 8, but we're saying it in a way that matches a number line. Right? Like, now think what this would look like if I were going to graph this on a number line. This is the easiest way to remember why you have to do this, I believe. Right, so there's our answer. Think what that would look like on a number line. So if that's the x-axis, well, I'm going to get two numbers. I'm going to get a number negative 12 and negative 8. And how do I graph that solution? X is greater than negative 12 and less than negative 8. What's that going to look like if I graph it? Open circles. Good. So I'm going to get open circles, and what do? I want X is greater than negative 12. So I'm going to connect them, aren't I? I'm going to go to the right of negative 12, and less than negative 8 means to the left of negative 8, so it's just the stuff in the middle, right? Get that? Okay? Okay, so let's try something like this. Okay, what's the answer to this one? Right away you can tell. The absolute value of 2x minus 24. So the absolute value is less than negative 20. Is that possible?
No.
The absolute value of anything is always got to be what? Positive. So no matter what value I plug in for x there, I'm going to get a value that's either positive or maybe 0, but it can't be negative, can it? So how could the absolute value, the output of that absolute value, ever be less than a negative number? It's impossible. The smallest it could ever be is 0, right? Everybody see that's no solution, right? Everybody get that? Okay. So this one has to be no solution, right? Because that doesn't make any sense, okay? Take a picture of that for the notes. Okay, what about one like this? That's equally ridiculous, kind of, isn't it? Yeah. This is saying that we want to solve for what values of x are going to make this true. The absolute value of 2x minus 4. No matter what I put in for x, it can't be negative, right? It's got to be 0 or positive, agreed? So then, when is that output of that absolute value going to be greater than a negative? Does it matter? I mean, always, right? It doesn't matter what value I plug in there for x. When I take the absolute value, it's always going to be bigger than negative 18, right? So what's the solution for this one? I don't think I told you guys how to, well, I think I told you guys how to do this one. No wonder you're having trouble with it. Okay, there's a couple ways you can do it. Well, there's one way you can do it for sure, right? Because it's all real numbers. So what values of x are going to work? Any value of x, or anything greater than negative infinity and less than positive infinity. Okay? I want to see if there's another way. I might have put in a little shortcut for you. Okay, so that's obviously going to work. But let me try something else here. Start again. Okay, I want to see if this works. Oh, it doesn't. Doesn't let you do it. Try one more. No, it doesn't let you do it. Okay, so you have to do it this way. I'll take a picture so you guys can see that. So if the answer is infinite solutions, if any value of x works, we have to use the way that we talked about last unit. Okay, we got it. We got to do it this way. Okay. All right, so let's look at, that was 4.2. Let's take a quick stroll through 4.3. See if there's anything in there that we need to fine tune. Okay, look at this one. Convert this to general form. That's our general form, same as standard form, right? Some books call it general form, some books call it standard form. So what would I do to convert that into ax squared plus bx plus c form? And if this isn't leaping to your mind, you got to go back and look at the notes a little bit. We said standard form is simplified form, right? Yeah. So I just multiply it out and collect like terms. That's all I do. Right? I'm just going to FOIL this thing out, simplify that, and then I'm going to distribute a 4 all the way through. Whatever I get, I get. That's no big deal. That's easy to do. That one's no problem. So just multiply it all out, and it's in. It's in the notes. It's in the videos. If you want to look at an example, it's there. What about one like this? Want to put it into general form. So I'm trying to put it into the form ax squared plus bx plus c, where a, b, and c are just numbers. What do? That's simplified form, right? Simplify it. Just multiply it all out and collect like terms. So I'm going to expand out the x plus 2 squared, x plus 2 times x plus 2, right? After I do that, I'm going to distribute the 2 through to everything, whatever I get when I multiply that out. And then finally, I'm just going to add 10 to whatever the constant is, add like terms, and I'm done. Okay, once again, no big deal. We went through lots of examples of that. If you need to look at one, they're all in the notes in the videos and the textbook, the PDFs. So those, no big deal. Now this stuff here, I'll pick the hardest one I can. So if I want to put this into factored form, right? Remember what factored form? We had 3 different forms of quadratic functions that we've talked about. We had standard form, ax squared plus bx plus c. For f of x, we had vertex form from unit 3. We did a ton of stuff with that, right? Vertex form, f of x equals a times x minus h squared plus k. And then we had, the new one was factored form. A times x minus p times x minus q. If that's not making a lot of sense, you're not remembering that, you got to probably go back and look through the PDFs and the notes and stuff a little bit. We want to get into this form, right? That's just factoring. That's all we're doing is factoring. So how would we factor this? What would we do? That's literally, these are the exact same problems. If you go back and look in Unit 2, these are the exact problems we did in Unit 2, word for word. So what do we do to factor that? It's the first thing we do. We're going to factor that. Think back to Unit 2. No, can't isolate. Different. Say it again. Well, if there were, we would, but there aren't any. But I thought I heard somebody say something. Well, eventually, no, we don't want, no, you guys are jumping to, you're going wrong turns here. We don't need to do anything that hard. If we're factoring, first thing we want to do is try to factor out a greatest common factor, right? What can we undistribute? -2, right? We could undistribute a -2 from everything. Well, if I undistribute a -2, what's left? X squared, good. Well, careful. Plus X, good. Minus 90. How did we get that stuff? Well, all we did was just divide if I factor out a -2, I'm just dividing everything by -2, right? So if I divide -2x squared by -2, not -2x, by -2, doesn't that just give me x squared? Right? And if I divide -2x by -2, that just gives me x. And if I divide 180 by -2, that gives me -90, right? So there's first step. You factor out the GCF. Right? Well, that's just going to be, that's just A, isn't it? Right? That's the number that's out in front when I write it in factored form. Okay? What's next? Now, what did we do in Unit 2 when we had a trinomial like this where A is equal to 1 inside the parentheses? What did we do? We're trying to factor that. It's been a little while, but what do we do? We're trying to break it apart into factors, right? Yeah, okay, good. So we want it to break it apart into factors. Well, we know that if it works, those have to be x's because when I distribute, x times x is x squared. But we got to get magic numbers. What do they have to multiply to? -90, and they got to add to 1, exactly, right? So what numbers are going to multiply to -90 and add to 1? You're going to multiply to a negative, so what's that tell you about the signs? Positive and negative. And what would they be if they're going to add to 1 and multiply to -90? Okay, positive 10 and -9. There we go. We got it. That's in factored form. That's our answer, right? That's in the form A times x minus p times x minus q. So all that means is we're factoring. That's all we're doing. We're putting something into factored form. We're just doing the stuff we did in Unit 2. We're factoring. Okay? And then finally, the ones I do want to review, because these are the ones that are kind of new, and, well, we did this in Unit 2 also, but I think these are a little harder. I'll do a hard one. Hardest one I could pick, this guy right here. Okay, so what about this? Now I want to put this into vertex form, right? So what was our process for getting from here into that form?
Raise.
Well, I mean, yeah, I mean, there's more than one way you could theoretically do this. But this is the stuff we did in Unit 2. What do we have right here? Perfect square, right? So this is that whole process of completing the square, right? Okay, everybody with me on that? So we've got to complete the square on this thing. What we're going to do, if we want to put this into vertex form, first of all, let's start off by, we've got this function, f of x. When are we out of here?
2 minutes.
No, we're not, are we? 6 minutes. Okay, so let's get through this one last example, and then I won't do anything new today. This is,
Hey,
all right.
review.
So I'm a little behind, but that's all right. So, okay, but I do want you, for 6 minutes, I want your absolute attention up here. We're going to get through this one. So remember, we're going to rehearse the steps that we do when we're going to try to complete the square to put something into vertex form. I want all those things, click them all the way closed if they're not closed, please. So the first thing we did was kind of dumb, maybe, but it helps. We're going to just rewrite the f of x as a y. So we get y equals negative 3x squared minus 24x minus 45. Remember that if we're going to complete the square on the right side, remember what we got to do. We got to get the right side to look like x squared plus bx, right? X squared plus some number times x. Okay, gotcha. All right, thanks. Okay, so what are the things we have to do to the right side to get it in that form? It's got to look like x squared plus some number times x. It doesn't look like that now. What do we got to do to get it there? That's all we want, right? To complete the square. What are the things that don't look like that?
We get 45.
Okay, the 45. We got to add 45 to both sides. We got to get rid of that, don't we? Right? So there's one thing. We're going to add 45 to both sides. Okay, that gets us closer to where we need to be. So I end up with y plus 45 equals, those cancel, so I get negative 3x squared minus 24x. What else is wrong? Something else doesn't look quite right here. It's got to look like x squared plus bx. That's not x squared. It's negative 3x squared. So what do I have to do? Divide by negative 3. We're going to divide both sides by negative 3. Okay, what's that going to give me if I do that? Well, that's the same thing as dividing each of these separately, right? Everybody agree?
Yeah.
So I'm going to get, what's negative 3 over negative 3? So I'm going to get x squared, negative 24 over negative 3 plus 8. Everybody agree? I'm going to divide each of those terms separately by the common denominator, negative 3. Okay? On the other side, this looks like kind of a mess. But that's okay, because we're just going to end up reversing all these steps to get to y by itself eventually, right? So everybody up here, please. I feel like I'm losing some people. So we got this in the position we need to complete the square, right? So to complete the square then, what's the number that I've got to add to this side to make it into a perfect square trinomial? This goes back to Unit 2. 16 is right, because half of b is equal to 8, right? Half of 8 is 4, and so 4 squared is 16. Now I got to treat both sides equally, so I'm going to add a 16 to both sides. So then what perfect square do we get on the right side? X plus 4, right? Okay, on the other side we've got y plus 45 all over negative 3 plus 16. So I got to get that y by itself. Now I'm going to go through and undo all the steps that we just did. So the first thing I'm going to do is I'm going to undo adding 16 to both sides. I'll subtract 16 away, because my job now is to isolate the y, right? So if I subtract 16, that goes away, right? Now I'm going to undo dividing by negative 3. I'm going to multiply each side by negative 3. So I've got y plus 45 divided by -3. I'm going to multiply the whole thing by -3, so those cancel. Well, that's the same thing as multiplying this whole side by -3, right? I've got to distribute it to both parts, though. Right, so I'm going to distribute the -3 to both parts, and what's that give me? Oh, what happened there? Everybody with me? Okay, last step is what now? What's the one last thing I got to do to get the y by itself? Subtract 45 and we're done. And then I could just combine those numbers, couldn't I? 3. Then we got it. Oh, how about that for timing?